Hey gang, today we're going to be starting a unit on what is called transformations. And transformations is dealing with shapes on a coordinate plane and moving them all around the coordinate plane. There's not that much math involved. It's just being able to manipulate an object to move it around the coordinate plane. So it's really important that for this unit you know how to graph coordinates and you can do it well. Otherwise it's going to make this very challenging. All right, so our first transformation that we're going to work on is what we call a translation. Let's see what that means. A translation, sometimes called a slide, is the movement of a figure from one position to another without turning it. In a translation, every point on the original figure is moved the same distance and same direction. The image is congruent to the original figure. A translation rule is written as x plus a and y plus b, with a and b showing the vertical and horizontal shifts. So here's our first example. So first we have to start with graphing those letters, M, A, T, and H. So M is at 0, 0, which we know is the origin. A is at negative 6, 0, so we go 6 to the left and stay at 0. T is at negative 5, 6, so we go 5 to the left and up 6. And really we should label these as we go so we don't get confused. And H is at negative 1, 6. Then you should take a straight edge and neatly draw what winds up being a trapezoid from M to A to T to H. So we have a trapezoid there that we're going to slide or translate to the right 5 units and down 1 unit. So since it's a translation, it's kind of like a slide. We can think of slide to the left and slide to the right, kind of like in the cha-cha slide. All right, so we have to go x plus 5 and y minus 1, which means we're going 5 to the right and 1 down. We could start by rewriting the coordinates. So if we have m, now that's going to become what's called m prime. That prime side designates that one transformation is occurring here. And since it's going to, starting at 0, 0, we're going plus 5. So 0 plus 5 is 5. And 0 minus 1 is negative 1. So our first coordinate m prime is going to be 5, negative 1. So we go over 5 to the right and down 1. And we label that m prime. Then our a prime, if we start at negative 6 and add 5, we get negative 1. And if we start at 0 and go down 1, we have negative 1 as well. So for a, we have negative 1, negative 1 right here. That's our a prime. Then for t, we have negative 5, 6 that we have to move right 5 and down 1. So negative 5 plus 5 is 0. And 6 minus 1 is 5. So t is going to be at 0, 5. So we stay at 0 and go up to 5 and label that t prime. And then lastly, we have h. And h is currently at negative 1, 6. And we're going to show that we're moving it right 5 and down 1. Negative 1 plus 5 is 4. And 6 minus 1 is 5. So h prime is going to be at 4, 5. Right here. And we draw our new shape there. And we can see that it is exactly the same size and shape of the original math and that all points were just shifted over. So, for example, if you look closely, you can see that this M went right 5 and down 1. This A went right 5 and down 1. This T went right 5 and down 1. And this H went right 5 and down 1. Now, of course, you don't have to draw that in. I just wanted to point it out to you. So this whole thing was shifted or translated 5 right and 1 unit down. That's what we call a translation. All right, let's take a look at another example. So now we have rule that we're going to slide to the left 6 and up 8. Left 6 is minus 6, and plus 8 is up 8. So we start with r being 0, negative 4. That's 0 on the origin and then down 4. Label it r. U is 4, negative 2. So that's right 4 and down 2. L is 6, negative 4. So that's right 6 and down 4. And E is 4, negative 6. So that's right 4 and down 6. Then, nice and neat, with a straight edge, draw your shape. We get something that looks like a rhombus or a kite on its side. Technically a rhombus though. Okay, so there's our shape. And again, we have to move it left 6 and up 8. So we could do the math. R prime, if we do 0 minus 6 is going to be negative 6, and negative 4 plus 8 is going to be 4. So we have negative 6, 4 for our new R. That means we go left 6 and up 4. And this is where R prime should be located. Then U prime, we're going to again do 4 minus 6, which is negative 2. And then negative 2 plus 8 is 6. So U is going to be at negative 2, positive 6, left 2, up 6 is right here for U prime. Then L prime is 6 minus 6, or 0, and negative 4 plus 8, which is 4. So we stay at 0 and go up 4 for L prime. And then E prime is 4 minus 6, which is negative 2, and negative 6 plus 8, which is positive 2. So negative 2 is left 2, up 2 for E prime, making this our new shape. And again, if we were looking really closely, you would see that each point is shifted left 6 and up 8, left 6 and up 8, left 6 and up 8, and last left 6 and up 8, making our transformation result in a exactly the same shape, congruent shape, just in a different position on the coordinate plane. Okay, so hopefully that all makes some sense to you, because you're going to try some on your own. Go ahead and try 3 through 5, then come back for the algebraic piece. All right, so here for number 6, we have triangle ABC was translated to triangle ABC prime along the vector shown below. Find x and y and the area of both triangles. All right, so again, remember, when we have a translation, the shapes wind up being exactly the same. They are congruent. So the parts of these triangles are going to be congruent. So we can set 4y plus 5 equal to 10y minus 10. We subtract 4y from both sides. We get 5 equals 6y minus 10. We add 10 to both sides. We get 6y equals 15. And then we divide by 6, and we get y equals 2.5. Okay, so our y value is 2.5, so we can plug that in. 4 times 2.5 is 8, or sorry, is 10, and 10 plus 5 is 15, so this side is 15. So this side should also be 15. If we do 10 times 2.5, we get 30. Nope, sorry, we get 25, and 25 minus 10 is also 15, proving that they are congruent. Okay, then we have to do the same for the x's. So now we have 8x minus 4 equals 6x plus 12. We subtract 6x from both sides. So 2x minus 4 equals 12. Then we can add 4 to both sides. So 2x equals 16. And then divide by 2. So x equals 8. Then plugging that in, 8 times 8 is 64, minus 4 makes this side 60. Then over here, 6 times 8 is 48, plus 12 is also 60. Okay, so this isn't drawn to scale, so I know this side here, this 15, seems a lot smaller than this 60, but the point here is to be able to algebraically solve for both x and y. So now that's just the sides. We have 15 by 60. Notice that it asks for the area. So we have to do one more step. Area is base times height. So we have 15 times 60, which if you guys know 6 times 15 is 90. So this is going to be 900. And it doesn't tell us the unit, so it's units squared because we had area. All right. So now you can try your exit tickets and then move on to your homework.